Welcome to this explainer. You know, when most people think of a terminal user, they picture this hacker wizard huddled over a glowing green screen just typing cryptic text. Well, today, we're going to totally shatter that stereotype. We're actually going to peek right under the hood of modern development and see how today's tools are completely transforming the command line. So let's just dive right into it.
The first big question we've got to tackle is this: is the default terminal dead? I mean, for the longest time, the standard terminal app that comes bundled on macOS, it's been totally fine for casual users. But we really have to ask if tools like that are becoming obsolete for power users. Because if you're someone who's, renaming hundreds of files, logging into remote servers, or compiling heavy code, you absolutely need speed and flexibility. And honestly, for those heavier workflows, the default options can start to feel noticeably sluggish.
The contrast here is actually pretty stark. On one hand, you've got the standard Apple terminal, where trying to customize it forces you into this rather clunky graphical interface. But on the other hand, we have a serious new contender, Ghostty. Ghostty is a free, cross-platform terminal emulator, and it is built entirely around speed, flexibility, and clarity. Instead of fighting a slow GUI, Ghostty uses a single-file text configuration. It's so simple. You just hit Command, up pops a blank text file, and you type in your parameters. Plus, Ghostty is unbelievably fast, mostly because it uses GPU rendering to draw everything on your screen.
And what's really fascinating is exactly what that GPU acceleration actually unlocks. Ghostty brings some insanely sharp modern features to the table. We're talking incredibly crisp text rendering, which, let's be real, is an absolute must if you're staring at a command line all day. But even better, native split panes. A single Ghostty window can hold two or more subpanes stacked horizontally, vertically, or both. It makes side-by-side file comparisons a total breeze. It also fully supports powerline glyphs, so you can display these beautiful little icons right next to your files and folders directly inside the shell.
But hey, Ghostty isn't the only one pushing boundaries here. The innovation is happening across the entire ecosystem. For instance, the terminal emulator Kitty just dropped its 0.48 update, and it is bringing some serious heat, too. The absolute standout feature here is vertical tabs. You can now place your tab bar along the left or right edge of the window, which perfectly optimizes your space if you're using an ultra-wide monitor. They've also added these transient graphics hints, meaning the terminal can now efficiently handle short-lived images that are only meant to be visible for a brief moment. Oh, and they rolled out fixes for fractional scaling on Wayland displays. The whole terminal space is just innovating incredibly fast right now.
So we know these tools are blazing fast and super polished from a user's perspective, but it begs a really fascinating question. How do you actually build non-trivial features for these complex terminal emulators today? Let's pull back the curtain for a second. We're going to pivot from the user's perspective over to the maker's perspective by looking at how a renowned developer actually used an AI agent to build a pretty complex feature.
Section 1. Building Ghostty with AI. A behind-the-scenes case study.
Every great feature starts with a frustrating problem, right? Renowned developer Mitchell Hashimoto was actually watching a high-profile OpenAI keynote when a live demo was rudely interrupted right on stage. What happened? A giant Ghostty update prompt popped up and completely grabbed focus. Yikes! So, using an AI coding agent called AMP, Hashimoto wanted to make absolutely sure that never happened again to any user. His goal was to utilize the Sparkle framework, which is a very popular macOS update system, to create completely unobtrusive, non-modal macOS update notifications. Basically, the updates needed to happen without popping up windows or stealing focus, so your workflow is never interrupted again.
Now, you might be thinking he just typed build the feature into the AI and walked away, but Hashimoto's approach is way more nuanced than that. As he puts it, AI is a very good prototyper. He bridges the gap by using AI not as a total replacement for human coding, but more like a muse for that incredibly difficult 0 to 1 stage of UI creation. Think about it. When you have a vague idea but you don't know exactly what you want it to look like, the AI is absolutely perfect for just getting a first draft on the board.
Hashimoto's actual methodology for pulling this off distills down into 4 totally digestible, repeatable steps. Step 1. Plan with the Oracle. Step 2. Prototype the UI. Step 3. Clean up the slop. And Step 4. Human review. We are going to walk through exactly how he executed this loop to build that update feature from scratch.
All right, let's start with step 1, planning. So what exactly is the Oracle? Well, in Hashimoto's toolkit, the Oracle is an AMP-specific read-only subagent. It relies on a slower, higher-cost AI model that is specifically tuned just for thinking and planning. Hashimoto feeds it his rough ideas and literally asks it to generate a plan before a single line of code is written. By interacting with the Oracle first, he gets a rock-solid architectural plan in place, which completely avoids the trap of letting the AI just burn through tokens writing useless code based on vague instructions.
Okay, so once the plan was set, Hashimoto had the AI prototype the Swift UI views. And at first, it looked directionally great. But then, he hit a wall. He entered what he hilariously calls the slop zone. See, the AI's initial Swift UI code introduced a critical bug where the update view wasn't visible at all when standard native macOS tabs were used. The AI completely failed to fix it and just started generating more and more broken code. This is a crucial lesson for us. Hashimoto quickly recognized the exact moment when the AI stopped being a solution and became a massive liability.
So, what do you do when your AI hits a wall like that? You run an anti-slop session. This is Hashimoto's crucial concept, where mandatory human intervention comes into play. Instead of just banging his head against the AI prompt over and over, he stepped in manually. He refactored the view models, moved methods around, and actually wrote standard human documentation directly in the code. Why? Because clean, well-organized, and well-documented code acts as a vastly superior guide for future AI prompts. Basically, you have to tidy the house so the AI knows how to navigate it.
So how did all that cleanup actually solve the critical bug? Well, it didn't immediately. After his cleanup, Hashimoto tried to guide the AI to fix the tab bar constraints 4 separate times. Vague prompts, specific prompts, it failed every single time. So acting as the lead human developer, Hashimoto made a critical pivot. Instead of fighting Apple's title bar integrations, he decided to place the update notification as a bottom right window overlay instead. He gave the AI this new, highly specific instruction, and boom, it nailed it perfectly.
With the front-end UI finally looking good, Hashimoto moved to the back-end to scaffold the SPU user driver business logic. He gave the AI his fresh documentation and asked it to fill in the blanks. And the result? Honestly, terrible. The AI completely conflated concerns and stored the state incorrectly. But Hashimoto realized the AI failed because the middle layer view model was structured poorly to begin with. So once again, the human steps in. He manually restructured the view model into a cleaner tagged union, which is essentially just organizing the data structure so it was mathematically impossible for the AI to confuse different states. By fixing the data structure himself, he successfully set the AI up for a win on the very next pass.
The really crucial takeaway here is that AI absolutely thrives when the human provides a solid foundation. In the last mile of development, the AI became incredibly useful again. Hashimoto handed off all those tedious final tasks to the agent. It flawlessly generated simulation scenarios for the happy paths and error states so we could easily test the UI. It then successfully hooked up the final update controller class to bridge the front end and back end. It handled all the tedious legwork while he essentially just guided the ship.
Now let's talk about efficiency, because this timeline is just staggering. The entire wall clock journey for this non-trivial feature was about 8 hours, spread across 3 days. But here is the real magic of agentic coding. Hashimoto was heavily multitasking. While the AI was churning away generating code in the background, he was actively shipping other Ghostty updates, doing interviews, and literally making breakfast for his family. The AI works while the human steps away. It's a game changer.
The magic number for this whole process is 16. That is exactly how many separate AI agent sessions it took to reach completion. It wasn't just one magical, perfectly crafted prompt that built the whole feature. That's a myth. It was 16 distinct, managed interactions, planning, prototyping, failing, cleaning up, and executing that last mile.
And the cost for all of this cloud compute? $15.98. That is the total token cost spent on the AMP agent to build, troubleshoot, and finalize this highly polished, production-ready macOS feature. As Hashimoto joked, he probably spent more than that on coffee during the 2 calendar days he actually worked on it.
But before we wrap up, we absolutely have to highlight Hashimoto's golden rule. Notice the stern warning here. Human expertise remains absolutely paramount. He emphasizes that developers should never, ever ship AI-written code without a thorough, final manual review. You have to understand the code that is going into your application. The AI is a powerful assistant, it's an incredible prototyper, and it is a tireless typist, but make no mistake, you are still the architect.
Which brings us to our final thought. We've seen how Ghostty is redefining the terminal experience, and we've looked closely at how one of the industry's top-tier developers uses AI to do the heavy lifting of building those modern features. It completely demystifies the magic, doesn't it? So, I want to leave you with this provocative question to take away.
If a master tinkerer can build a non-trivial production-grade application feature for under $16, what could you build for $15.98?